All right. So we'll talk about a few terms that come with the journey. We'll talk about data is. So data, everybody understands what data is. Now there are two kinds of data. There's primary data and there's secondary data. The primary data, these are very simple terms, indicative, literal meaning is very close to what they actually mean. Now, when you've got a project at hand, let's say you've got a question that you want to answer, and in the effort of answering that question, let's say you've gone out and collected some data. Now, the data that you've collected to answer a specific question, that data becomes the primary data for that problem statement. So primary data is something that is associated to a problem statement. So any data that is collected for the purpose of solving a problem that you've got at your hands, that kind of a data is called primary data. Whereas data sets that are used, so let's say a data set was collected for some purpose. Let's say, think about the census data. Census data is a huge, vast repository of information. It's got information on all kinds of things. You can plan how many schools you need in a particular district. You can plan how many water tanks you need in a particular district. You can plan, n number of questions can be solved looking at census data. But then the census data was created for some unified purpose. Maybe it was a population registry. You wanted to understand, get a sense of what the population is like. So for computing or getting a sense, estimating the population, census data was the primary data. But all these other analysis that you can conduct using the census data, in those cases, the census data becomes a secondary data source. So secondary data is anything that's been compiled already for some other purpose, but is now being integrated and used for some other problem altogether. Those kinds of data sets are secondary data sets. A very good example for that is census data. So you collect that every 10 years, let's say in India, and it takes about a year to collect it. Yes. You're saying something?
Yeah. Can we take Can we take secondary data as a kind of reference data?
Secondary. I couldn't hear you actually.
What I'm asking was, can you consider secondary data as a kind of reference data to your primary? Am I audible? Hello?
Yeah, I can hear you now. Reference data, you say reference data, but then it depends on the context that you're saying it in. What do you mean by reference? Secondary data, the fundamental definition, the way we define it is what I've told you, which means that if your data was not compiled for the project that you are running it on, then it becomes a secondary data for that project or for that problem statement. That's how you define secondary data. Now you can call it out in different ways. I'm going to leave it up to you. You can explain it in different ways. But then if a data source was created for a particular project, for a particular problem statement, solve a particular problem statement, then it becomes a primary data for that. In rest of all other cases, that data set for all other problem statements, it's a secondary data source. You calculated, like heights, weights of all kids. You only needed the heights. The weights you used for some other project, then that data set becomes secondary for that project. And the project that you used it for heights, that becomes your primary data source. You get my point? See, these are definitions. So you can't do a lot in terms of altering it.
Yes, thanks.
These are simple definitions. You got to take it as it is. The way you use these terms can be, far and different. Different ways in which you can use these terms, but then this is how it's defined. Then you got simple things like a variable, a constant. I think we're all familiar with what these are. You come out of a programming course. You anyways have a good clue of what variables and constants are. We'll talk about two kinds of data sources or kinds of data that you can come across. One is a qualitative data source where you're looking at categorical inputs, things like, gender or education degree that you have, any data set that contains discrete values, discrete categorical levels, I would say. That kind of a data set is called qualitative data. And not a data set, but an attribute or an information or a column that you capture in any tabular data. Any information that comes off as unique levels, it's not continuous in nature, it's called qualitative. The opposite of that is quantitative. So things like age, weight, height, these are columns that you typically would consider as quantitative columns. Whereas columns where you store categorical factor values, levels, Those kinds of columns are called qualitative data points. Now, the distinctions between these, so you can break down your variables into different kinds. The very basic break is this qualitative and quantitative. Inside qualitative, you can have dichotomic or polynomic. Dichotomic would be, when you have only two categories inside that particular column. So let's say a gender or so here you've got an example for marital status, but these can all be polynomic variables as well, where you've got more than two categories inside it. But then the way you store your data, it depends on that. If a particular qualitative variable has only two categories, unique categories that can form a part of it, it would be called a dichotomic variable. Dimensions are qualitative. Dimensions, by dimensions you mean attributes, right? Dimensions in the data science sense. If you're calling your attributes as dimensions, yes, then they are qualitative or quantitative attributes, true. So any column, simple terms, any column that you have in your data set, if it's storing categorical values, then it's qualitative. Inside qualitative, you can have dichotomic, which means that it has only two unique categories in it. Or you can have polynomic, where it can have multiple unique categories. So what's your education level? What's the brand of the computer that you own? What's your hair color? These could be examples of polynomic qualitative variables. Similarly, if you got quantitative data, then in quantitative data, again, you can have either discrete or continuous. Now, this discrete is different from categorical levels. Here, discrete is data that is still stored as numbers, but it can only take whole numbers, let's say. So number of children that you have in your family. So it cannot be 2.5 or 3.5. It can only be 2 or 3 or 4 or whatever it is, or 1. So these kinds of questions where you don't have, floating point values as possible values inside that column, those data sets would be called discrete. Whereas once,
Sorry, can we treat this as a polynomial qualitative variable, number of children in a family?
you can treat it like that, yes.
Okay.
If let's say it depends on what's the level of variance that you have in that column. So let's say number of children is a variable which will at best have 10 or 12 unique values in it. Worst case scenario, if you have Mr. Lalu Yadav also in the data set, then you can probably go up to a large number. But in a modern family, you don't have more than 3 or 2 or 4, those number of children, at least what's happening now. In our parents' generations, we had more number of kids, but if you've got very few unique values that you have in your quantitative variable, then you can treat it as a polynomial qualitative as well. Now that depends on how you enter it into the model. If you're using a modeling approach, and how you store it is going to decide whether it gets treated as a polynomial qualitative or a discrete quantitative. I mean, the way the model is going to read it is going to be similar, sort of similar. With continuous.
But Rahul, the mere fact that you're using numbers, will it be the reason why it cannot be categorized as qualitative?
True. If you're using numbers for it, then it cannot be called qualitative.
Yeah.
If you're using characters, it cannot be called quantitative. Even if they behave similarly, like she said, you can't interchangeably use the words. Qualitative ensures that it's a character variable. Quantitative ensures that it's a numerical
variable. Yeah.
True.
Rahul, polynomic means it's a multiple, is it like more than 2? That's
Yes.
why you have taken the brand.
More than
and the dichotomic, I mean, the other one is the individual.
Two. Dichotomic means there are only two levels. If there's only one level in an attribute, that attribute is useless. You understand?
Okay.
If you have a column that only has one value for all the rows, then that column is useless for you. It does not give you any new information, or at least it does not give the model any new information. If you, let's say you're trying to understand, let's say you're a bank and you're trying to understand whether a particular credit card customer is going to default or not. And if one of the columns is gender and you're storing data for 9,000 males, then will gender be effective in helping you understand whether a person defaults or not? No, because everybody is a male, so there is no discrimination. you need at least two, right? So that's why there's no point of having a term for qualitative variables that have only one value, because then it's not even a variable, sort of like a constant. Yes?
Okay, sure.
The other side of discrete quantitative is continuous, where you can have a range of values, which means that we talk about these variables in terms of ranges and not the exact set of values. We say that, you know, age of a person can fall in a range. The amount of hours that you've put in, that can be in a range, or the amount of income tax you've paid, that can be a range of values. Not necessarily every row, it does not mean that every observation is a range of values. It just means that the entire column itself can be considered or talked of as a range, not as a set of distinct numbers that form part of that column. So that would be your continuous attributes that are quantitative in nature.